Yeah, I know it's something. $6. You know Dada? Yeah, be like us. Be like oh my god. Big bot. Yeah, yeah. It's like our daddy's for now, right?
Let's turn to let's start at page 20. And we're going to just get some more practice with volume by cross section. And then we'll move into our quiz review packet. And I'll also go over the calendar for the rest of the semester. So you can so I go over some what's going to happen after our Thanksgiving break. Okay, so page 20, we have the boundary region for each problem that represents the base of a solid. So we have to kind of the shape of the base doesn't really matter. It's the fact that think of this as that shaded region is flat surface of your. Oh yes. So think of this as a flat surface on a piece of paper, and we're building different shapes that's going to come out of the page. So it could be a triangle, it could be a semicircle, it could be a square. And again, we don't have to worry about what these objects look like. We just have to be able to gather enough data and put it into the formula and identify the volume. So let's find the volume of each solid based on the given cross sections, set up the integral first, and then use the calculator to evaluate. Okay, so we have isosceles right triangle with leg on the base. And you're always going to be provided the exact direction to draw your base length. So in this case, parallel to the y-axis. Which direction is that? It's vertical. So you're always going to be connecting from one boundary to the other. So vertical is always going to be easier because you can rely on just the equations given to you. There's no need to rewrite anything. So the top of my base length is sitting on the root x minus 1. The bottom is sitting on the 0. So with cross section, you're kind of building one dimension at a time. So your one-dimensional length is root x minus 1. Next up, you're moving to the second dimension, which is area. And there's an area formula for isosceles right triangle with leg on a base. Remember, again, it feels intimidating having to memorize all the formulas for these volume by cross section areas, but they're all involving base squared, except for rectangle. Rectangle is base times height, but base squared, I just have to worry about what's the coefficient in front that's going to make the formula a little bit different. So with leg on the base, isosceles right triangle is 1/2, so 1/2 base squared. So update the formula with the specific base length. And so imagine these triangles are coming out of the page, and we're extending, thank you, from as far left of the shaded region to as far right. So as far left is 1, as far right is 3. And to get to that third dimension, we just put the integral notation around it. I'm just doing a little bit of cleanup. The square root and square will just cancel each other out. Okay, the rest gets plugged into your calculator. And remember, this is not, there's no rotation here. There's no axis of revolution. There's no pi involved. So it's just that value. Okay, try number 6. This case, perpendicular to the y-axis. Y-axis starts off vertical, perpendicular. We have to change direction to horizontal. So horizontal base, if you see horizontal base, horizontal radius, horizontal rectangle, you know that your equation needs to be rewritten in a form that we can use. So this y equals root x minus 1 needs to be rewritten. Make sure that you don't just swap the x and y. You have to actually algebraically solve for x. So for both sides. The right boundary of my base length is x equals 3. Notice that we have equations that are in the form that we want. They're both in the form of x equals, and that means whatever's on the right side is ready for us to use for our right minus left. Okay, so one dimension at a time. Base length, right minus left. Right endpoint is sitting at 3. Left endpoint is sitting on the y squared plus 1. Protect the y squared plus 1 with a set of parentheses, so you can remind yourself to distribute. Okay, our second dimension is the area formula. So semicircle, area formula for a semicircle is pi over 8 base squared. And put the base that we're working with inside your formula. And then we're moving up to the third dimension. We want a volume out of this, so just put an integral dy, and then your bound is from 0 to wherever this intersection is. But rather than using the calculator and having to graph, remember, you can't graph vertical lines, but I mean, all we need to do is find the order pair here, right? We know that x value is 3. We just need to figure out the y value at that point. So it's just plug 3 into the function and solve for y. So 3 just goes in for our curve, and we're just looking for that y value on the curve. So 3 minus 1 is 2, root 2. So our bounds is from the lowest y value, 0, to the highest y value, root 2. The rest goes in your calculator. Or just do 1/8 and then leave pi out of it so that you can have a chance of providing exact value. But I think it ends up giving us a decimal. So round the 3 decimal places, attach pi at the end. All right, finish with 7. Try this one. Perpendicular to the x-axis. So x-axis starts off horizontal, perpendicular, making it vertical. So we know it's going to be an easier setup. No need to rewrite our equations. So base length is top minus bottom. Top is sitting on the square root function. Bottom is sitting at the y equals 0. Area formula is this is leg on the base, so it's 1/2 base squared. If it's hypotenuse on the base, it'll be 1/4 base squared. But we have 1/2 base squared. Update to our area formula. And actually a little bit of cleanup. Bound is from the furthest left to furthest right in terms of x. Left is -1, right is 1. Okay, let's just move on into our quiz review. The rest of the pages in the packet are just additional problems, which I included in the quiz review as well. So let's move on to that handout. Okay, so quiz review, if you can turn to the final page, the back page here, page 14, I just want to run through the formulas that we're going to be working on. So you can kind of have a big kind of overview. We start off with area. Area is just either top minus bottom or right minus left, depending on, I think usually with area we can choose. And usually I would say for area, our natural default should be, we should try top minus bottom first. And if that doesn't work, then we can shift to right minus left. So I think our default for area should be top minus bottom. But for this method, washer method, cross section, they're going to be there's going to be enough context clues for you to know exactly which formula to use. Either it depends on the direction of your axis of revolution for your distance wash method. And then for volume by cross section, it'll tell you exactly. It'll say parallel or perpendicular to the x or y axis. So for our volume, you're going to be told explicitly how to draw your, which orientation to draw your base length or your radius. But for area, you might be able to choose, but I would say always start with top minus bottom first. So remember, with this washer method, our radius is squared. For washer method, make sure that your big R and your little r are squared separately. And then for cross section, we just did those, and we have formulas associated with it. Most formulas are involving base squared, except for rectangle. Now, we've spent most of our time doing volume, and so we're used to the idea that things are being squared. I want to remind us that with area, typically what I see on the quiz is students, they set up the formula for area and they feel like something is missing. So I see the students wanting to put a squared as part of their formula because they feel like something is missing. But your area is going to be simpler because it's just going to be a two-dimensional calculation. So it's just top minus bottom, and that's it. There's no square, there's no pi in front, and it feels a little bare compared to volume, and it should be because it's not three-dimensional calculation. So just keep that in mind. Those are the mistakes that I see sometimes with area. All right, so let's start with 1. All right, given the region enclosed by y equals root x minus 2, that's the curve on the left, y equals pi minus x, line on the right. Find the area of the region below. So I think our natural default should be, let's try top minus bottom first. But if we do top minus bottom and we want to find the area of this region, let me draw one representative rectangle. So imagine you're stacking these vertical rectangles from one end to the other. Am I going to get a consistent are my rectangles going to hit a consistent graph regardless of where this rectangle is? No, right? So there's going to be a change, right? This top graph is going to change to a different graph. So that means we need to create 2 integral formulas because we have 2 different relationships for a top function. So there's going to be a split. And we need to think of this as 2 separate regions. This region has a top graph that's represented by the square root. This region has a top graph that's represented by the linear. So start off with your calculator, and I mean the x-intercepts are identified for you, but we do need to find that intersection. So let's see if we can plug that in.
You also do it like horizontally.
Yes, yeah. So I think if we can do it both ways, just for practice purposes. So yes, we can do it top minus bottom here, and then after we get done with that, let's try it right minus left. Even though on the quiz you're not going to be asked to do it both ways, you can choose which way to do it. But when we do it right minus left, I think that is going to help us when we do part B and C, because these other volume problems may require some information. So But yeah, so for practice purposes, let's do top minus bottom first, and then we'll switch over to right minus left, see if we can make the proper adjustments. So this is what my Zoom 6 graph looks like. So I'm just going to zoom in, Zoom 1. I'm going to draw a box around this region. Second trace, 5, second trace intersect. Pick a point on one of the graphs near the intersection, hit enter. The blinking cursor will toggle to the other graph, hit enter, and hit enter a third time. It'll say guess question mark, and then it'll look for that intersection for you. Go ahead and write both the X and Y value down, even though right now we only need the X. We might need that Y value later on. So, so for, let me highlight. So for my left region, the top graph is root x minus 2. For the region on the right, the top graph is the 5 minus x. The bottom are represented by the x-axis, which is y equals 0. So top minus bottom for my left region, top minus bottom for my region on the right. Make sure your area formula looks a lot simpler. There's no pi, there's no parentheses squared. It's just top minus bottom, and that's it. Okay, yes.
We get points off if we didn't include the -0 in the.
No, I just want to show you that I'm following the formula, but you can drop the zeros. Let's try do right minus left again. If there's an option for you to do either top minus bottom or right minus left, you get to choose. You're not going to be asked to do it both ways. But I just want us to do this for practice purposes. And also doing right minus left will help us for parts B and C, since for volume, it may ask us to build these horizontal lens. So if you see a horizontal rectangle, horizontal radius, horizontal base length, you know you have to spend the time to rewrite the equations, and these equations are not going to be good for right minus left. So we want to solve for x here. Oops, sorry. My bad. I wrote the problem wrong here. Okay, so right minus left. We adjusted our equation here. The y equals 5 minus x. I rewrote it as x equals 5 minus y. The y equals root x minus 2. I rewrote it as x equals, after I squared both sides, x equals y squared plus 2. Sorry, not the area. Okay. Integral from the lowest to the highest y value, since we're stacking these rectangles from the lowest, which is our x-axis, all the way to that highest y value, which is 1.303. Right minus left, right endpoint is sitting on the linear, the 5 minus y. The left endpoint is sitting on the curve, the y squared plus 2. Put parentheses around the bottom or the right left function, the left equation, so we don't forget to distribute the negative through. Right, the rest goes in your calculator. On paper, you would write it in terms of y, but in the calculator, you will use x. We should get the same answer. Again, with area, we don't square anything. Any questions with one? Okay. All right, read part B and see if you can try this. A lot of the information that you've gathered from part A, we can reuse. So see if we can decide what to do here. So find the volume. We're rotating about the line x equals 1. Find the volume. So okay, we know that we have a rotation going on here. So it's either disk or washer method. Which one would it be? Washer method. Now, what if the dotted line was up here touching the curve at 2? Still washer. Why is that? I know it's touching, but why is it still a washer? Okay, it's not a flat surface. So the reason why I want to bring that up is sometimes students feel like, oh, if something is touching, that means it's this method. It's got to be touching, and there can't be any gaps. So basically, the only place on this region where it can be a this method is if the dotted line was right up against the x-axis, right? And also your axis is your rotation is never going to be a diagonal line. So even though there's a flat surface here, even if it was here, it'll be washer method. If it was here, still washer method. So it's got to be a flat surface touching the dotted line in order for it to be this method. Okay. So watch your method. So to radius. Make sure that you include the dotted line. I know, again, the dotted line feels like the edge of the diagram, but it's really the center of the diagram because this is going to get rotated all the way to the other side of the dotted line. So make sure your dotted line is included when you build your radius length. Okay, you can reuse a lot of data from our second method. We can reuse these equations. We can reuse the bounds. So see if you can finish setting up the rest of the problem. Okay, right minus left, 5 minus y minus 1. And then right minus left, y squared plus 2 minus 1. Our bounds from the lowest to highest y value from 0 to 1.303. And then big radius squared minus little radius squared dy. On paper, you'll use y variable, but in your calculator, you use x. Okay, part C. Part C is a cross section. So see if you can, same diagram. We can reuse a lot of information, but it's now a cross section problem. So part C. Now with cross section, you will be able to connect the boundaries of your shaded region. Remember, for washer method, we're never going to be connecting what's between the shaded region and calling it the radius. So it always has to extend outside of your shaded region to get to your radius. But for cross section, you will be, there's no rotation for cross section, so you are always connecting from one boundary to the next. Okay, so this is going to come out horizontal again, because the way that we want to draw the base length is perpendicular to the y-axis. So build your information one dimension at a time. Find the length of your base. Then identify your area formula to plug into your base. And then the third dimension is that integral dy, bookending your area formula. Your bounds will also be in terms of y. So lowest y value is 0, highest y value is 1.3. No pi involved with cross-section unless it's semicircle. Okay, page 2. Okay, so tomorrow, I'm just going to be checking pages 1 and 2. Whatever we don't finish on page 2 will be homework. We still have a little bit of time. We can get through 1 or 2 on page 2. Okay, so first, use your calculator to help you find those intersections that you need. To find this point, again, if you're trying to find a point and trying to graph a vertical line, you can't really do it. But this is easy. You can just plug 0 into this function and find your y value, right? You don't have to do any calculation work with your calculator. You can just plug in. You're just finding order pair on that curve. Okay, rotating about the line y equals 1. Here's my shaded region. Okay, rotation. Now this is what? This is this method. Okay, so notice the dotted line. The dotted line is up against the flat surface of the shaded region. There is no gaps. So all we need is one radius. And your radius always comes out forming a T with your dotted line. Okay. We're doing top minus bottom, so actually we don't need the y values. We just need the x values. Okay, spend a few minutes, try part B. I know we might not be finishing class, but at least we can start it. We can reuse a lot of the same information from part A. But now we have a different axis of revolution. Here, the dotted line is clearly not up against a flat surface of the shaded region. So we know there's a gap, there's a hole. We have to involve washer method. So we have to draw two radius, one that extends from the dotted line all the way to the furthest boundary, y equals 1. And the other dotted line, radius will extend from the dotted line to the curve. Big radius is going to be your longer length. Small radius will be your smaller length. Identify both your big R and little r. You use the same bounds as previously, since we're still same orientation, same graphs. And then make sure you're squaring your radius separately. So I'm going to be checking pages 1 and 2 tomorrow. So just one more problem to finish up. Now, I mean, we basically have gone over all different things that you're going to see on the quiz. So there's still plenty of time. Your quiz is not until next Thursday. So I'm still going to spend a little bit of each day doing review, but I would like to transition over to more of FRQ review, since we're going to have a couple of quizzes after the break. So I'll show you exactly what we're going to be working on in preparation for those quizzes. But we're still going to review a little bit each day, but less and less, since I'm hoping that you can do some of the practice on your own as well.
So there was you or econ? Oh, it's worth it.
Were you? I literally, waiting to
Only gonna have one.